Hello and welcome to the Martinus Institute's English YouTube channel. My name is Pernilla Rosell and I'm very happy to have a guest with me today.
Yeah, hello, thank you.
Welcome Nikolaj Petersen. You are a lecturer here at the Martinus Center, but you're also a philosopher and a teacher.
Yeah.
So you are perhaps known, I think, to many of our friends already. You have written a PhD in philosophy and you have talked about it in an earlier podcast.
Yeah, that's me.
It's had a very interesting title, and I think the only thing that makes us nervous when we want to invite you is that title is so tricky to pronounce, but I could give it a try. Non-constitutive cosmopsychism.
Yeah.
Naturalism, idealism, and Martinus's metaphysics in a synthesis.
Yeah, absolutely.
Yeah. So extremely exciting PhD. But Nikolaj has been interviewed about this in our podcast episode number 50, I think it is, in the Martinus Cosmology podcast. So I recommend all of you to listen to that in order to hear more about your work on reality, consciousness, and all those huge and very interesting and difficult questions. But you recently also visited the Martinus Institute in Copenhagen and talked about another topic. Philosophers are, of course, very broad, I think, coming from another area myself. And the title of the seminar was Bohr, Einstein, and Martinus.
Yes.
And we thought that was so interesting and so fascinating that we would like to talk a little about it in English as well. So that's why we invited you today.
Yeah, thank you.
And when you hear the names Bohr and Einstein, and especially in that combination, if you are sort of moderately acquainted with 20th century history, physics, quantum mechanics, you will probably associate those names with the debate that Bohr and Einstein had about those topics, even if we perhaps really don't understand what they talked about. But it was a debate that influenced many other physics as I understand it. And then you also bring in Martinus into that context.
Yeah.
So perhaps you could begin by telling us a little about what made you interested in this debate between Bohr and Einstein.
Yes, I've looked at it several years ago when I wrote a book about the question of the nature of reality, and I wanted to have various scientific points of view included as well. But then this time around, it was there's to be published a history of ideas in a Danish context, and they asked me to write a small chapter about Martinus, probably because of the PhD work.
Yeah.
And then they needed someone to do something on the Bohr-Einstein debate as well. And I said, all right, so if you don't have anyone else, then I can do it perhaps. And they said, all right, we'd like that. So I did some kind of some research, and I wrote a contribution to this this 3-volume history of ideas that'll be released in 2 years, I think. So that's why I digged into the topic more specifically this time around. Yeah. So it was not specifically in a philosophical context, but of course the overall frame is somewhat philosophical. Yeah.
Yeah. Because as far as I understand it, what I think makes that debate so fascinating, and perhaps you can just give us a brief overview of it, is not only that they disagree about this new world of quantum mechanics that they have discovered, but they also seem to touch on the deep question: what is reality? What can science say about reality? Should science try to say anything about reality, or should we just do experiments and build things?
Yes.
So it seems to have those two dimensions.
Yeah.
Is that?
Yeah, exactly. Yeah. So traditionally, physics is viewed as science that describes reality as it is. That's kind of the goal of physics, to describe it in mathematical ways. So, and Einstein would say that's what we want. We want to understand reality as it is. And Bohr, he said, well, all we have is the results of the experiments, and sometimes, especially when it's at the quantum level, so the things here are so small, it's at the subatomic level, that even the measurement of a physical object, if one can even talk about objects at this level, will impact the object. So if we try to measure for a specific property, will impact the object of that we try to measure, and that will make it difficult to get exact knowledge about it. So he would say, well, we cannot. Physics is not about what reality is; it's about what we can say about reality, and that's a big difference. So, according to Einstein, we want to understand reality, and Bohr, he would say, well, all we can do is we can describe the results of the various experiments and how we set up the experiments and such, and then we get various results. Yeah. So it's Bohr. It's an entirely new perspective on the nature of science in a way, or the overall goal of science. That it's not about describing reality in itself. It's more like, well, we have these results, and that's what's there.
And in a way, I remember you said at the seminar that if you sum it up, at least from a more practical perspective, it was Bohr's conclusions that sort of won the discussion at the time.
Yeah, it was. Yeah.
But what about later on? Have there been people who have brought up Einstein's perspective again and said it's not concluded yet?
It's not entirely concluded. So the development of quantum mechanics in the 1920s in Copenhagen, it was very significant, and the end result was that you cannot. There's a limit of how deep we can dig into this. So it's not just the equipment, but it's the way reality is structured that kind of prevents us from getting any deeper. So, and that's what is called the Copenhagen Interpretation of quantum mechanics. And that became, after the Bohr-Einstein debate, that became the kind of the generally accepted view on things, precisely because Bohr was considered to be the winner of this debate. And there has been some experiments later on that point in the same direction, but there are other interpretations as well, and it's not settled. And now, well, researchers, when they look back at the debate, there are some would say that, well, Bohr, he misunderstood some of Einstein's arguments, and so they would say it was not as conclusive as it was interpreted at the time, perhaps.
And then, of course, you bring in, or you brought in at our seminar, you bring in Martinus into this.
Yeah.
And actually, coming to think of it more from a historical perspective, it's not the first time that people who are interested in spiritual perspectives are attracted to the ideas of quantum physics or quantum mechanics. We can see that there have been lots of books published, and I even heard about it, that there was some educated physics but they were also part of the hippie movement. So they started their own, so they wanted to connect that to Eastern mysticism and so on. Right. I think that's very interesting thing from a broader perspective. These clearly sort of resonated also with people interested in spiritual things. Why is that, do you think?
Yeah, so according to quantum mechanics, if you look at an electron, for example, then if you measure it one way, then it has properties of a particle. And if you measure it in another way, then it had properties of a wave. And these two are entirely different, right? A particle is at a specific point in space, and a wave is, in a sense, all over the place, right? So usually you would say these two things are so different that how can something have the both those properties at the same time? And in philosophy, we have this problem of consciousness, the relation between consciousness and the physical world. And here it seems there is, so if we go really deep down to the quantum level of things, so at the subatomic level, there seems to be this duality of waves and particle. And perhaps one way to try to one way to interpret it perhaps is that the wave properties perhaps point in the direction of something that could lead to consciousness, perhaps, and the particle properties perhaps is pointing more towards matter or something. But I think it's somewhat speculative, I think. And but I'm not too acquainted with the the cutting edge research on philosophy, but there are some theories of quantum fields, for example, that everything is a huge sea of energy, and what we observe as particles are simply the top of the waves of this great ocean of energy, and viewed in that way, then everything is one. It's all connected, not merely like, we are all connected, but at the deepest level, it is all one. It's all united. It's all a single substance in a way. And that would match some of the Eastern ways of understanding reality or perceiving reality, I think. Yeah. But I don't know the specifics of the debates, but there has been a lot of it. I think there was a guy called Capra, perhaps, in the 70s, 80s, who wrote a book. Yeah.
So obviously, at least it had a great influence, and probably something we'll see more about. But if we just go back to Martinus, because Martinus is, well, you know very well, and without, we can't explain and get into all the details of his world picture right now, obviously, but you have the overview of Martinus's world picture, and then you see, for example, when Einstein said, as I understand it, there need to be a cause when we see an effect. It's not just coincidental. That can't be. He had that famous wording, God doesn't, what you say, cast dice.
Yeah, throw dice or whatever.
And so on. And then, of course, perhaps we don't see it in the physical world, but Martinus also talks about cause and effect.
So traditionally in physics, it's always a matter of physical cause and effect, right? And that leads to the determinism that Einstein is talking about, meaning that if we, at least in principle, if we know all about the causes and all the laws of nature, then we can, in principle, determine the effects. So it's all determined. Everything is determined, and that's why Einstein says, "Well, it's not a matter of just throwing a dice. It's not just random, right? It's determined according to the laws of nature." And Bohr, he says, "Well, we cannot go below this. There's this level that we cannot penetrate. We cannot go deeper than this because we cannot measure anything down here. So we cannot talk about any causes at this lower level." And Einstein, he would say, well, there has to be some causes. That's his, well, that's how science works. We can't just end it here. And so Martinus, he has a different view on cause of and effect. Of course, there are physical causes and physical effects, but it's fundamental causes are from the non-physical eye or center of the living being of the human being, for example. So the ultimate cause exists outside of the physical realm in a way. So it's all it's all a construction in a way. So of course there are physical cause and effect, but there are causes at a deeper level, at a non-physical level, according to Martinus, right?
Yeah.
But I think, according to his view, even if we only look at the physical cause and effects, then the cause and effects they continue downwards at a smaller and smaller scale. So he would agree with Einstein that of course there are causes at a deeper level, infinitely, right? So there are no ending. But he would also agree with Bohr and say, well, there are limits on our ability to perceive cause and effect, right? We are limited to our specific perspective on things and our ability to even understand what is happening. Everything gets clouded if we go to the very, very tiny details. We cannot understand anything. So I think his view is, Martinus' view is compatible with both Einstein and Bohr's views, even though those, well, the views of Bohr and Einstein are entirely opposite, but I think it would both of them would fit within the frame of Martinus' metaphysics or world picture.
But they were also, as we understand it, driven by sort of a friendly competitiveness. They were friends, and they wanted to find the truth. So they challenged each other's views, and then they got on. But as you say, as you described at the seminar, Einstein perhaps most clearly also had what he called, what you describe as a cosmic religious sort of inner absolute belief that there has to be some kind of order. This was counterintuitive to his belief. That's why he said, okay, there must be a cause.
Yes. And so he said, all right, of course I see your arguments, and it's in a way reasonable to kind of end it here like Bohr did, but he said, I can't. There's something within me that just can't accept this. There must be something more, right? Yeah, and you're right, he has this, and it's very interesting that such a famous scientist as Einstein, perhaps the most famous of all scientists, he has this view on reality, and he was very interested in Spinoza, a 17th century philosopher, but who had the view that everything was one substance, and it's all cause and effect, but it's also at the same time it's all one. Everything is one. It's all connected, and there's some kind of greater meaning in life, and the ultimate aim of science is to kind of to reveal all this, and that's a very different view than the kind of the standard materialist view on the dead matter. We just try to understand the laws of nature and describe the behavior of this stuff. So he's a very interesting character. And Bohr, he has something along those lines as well. He was very interested in Eastern philosophy and philosophy in general, and he had I think he was very open-minded as well. So I think they got along very well.
Because something that you also mentioned at your seminar is the importance of not just intelligence in order to, of course, do science and be a researcher, but also at what Martinus would also term intuition. Martinus actually mentions Bohr and Einstein briefly, actually as examples that he believed they had some intuition, otherwise they couldn't be such great scientists. So he gives credit to their great insights, also said they need to have some kind of intuition as well. And intuition, of course, as you also mentioned is a specific capacity that can only also open up if we have those other things that you mentioned, humaneness, a balance between feeling and intelligence, and then you sort of can start using also some intuition in your scientific work.
Yeah, that's right. And it's very interesting that a number of the people Bohr worked with, they explicitly mention his intuition. His way of being as a human being. He was very kind, and he had a lot of very good qualities as a human being. But this intuition was his brother. He said he has something like I don't remember the exact wording, but some kind of almost supernatural understanding or intuitive understanding of things. So it's interesting that it's mentioned that Bohr, he was extraordinarily intuitive in his approach to things. So he had an idea of how is this, and then he tried to get the physics or the math to match, right? So he kind of knew which direction to go in a way, perhaps. Yeah, but it's a matter of interpretation, of course. Yeah. But it's not like the traditional very, like, it's all a matter of reasoning and cold calculation. There's something else. And both of these characters or these personalities, they are very kind people and very well liked. Yeah. And they kind of, the people describing Bohr and worked with him, they're kind of underscoring this aspect of him. Yeah. And that's perhaps somewhat unusual. I think some of the scientists, perhaps they're very, well, I don't know, but they can be nice people as well, but some of them are, it's perhaps more a matter of competing and getting results and stuff. And I think for Bohr, it was something else. One of the people working in Copenhagen, he said, for Bohr, at the end, it was a matter of trying to understand, well, the world and existence and life and like the philosophical questions. So physics was kind of the frame he worked within, but at the end, it was the philosophical questions. So he had his aim was much bigger than simply scientific in a narrow sense, I think. Yeah.
Not so utilitaristic. He was sort of really searching knowledge.
Yeah, and existential knowledge in a way.
Yeah. So other thing that you mentioned, which I thought was interesting, because that's more my area or my background, is when they started to describe what you just said, particles and waves. You actually said that these are words that were coined by an earlier view of physics.
Yes.
The way I understand it. So in a way, they're not adequate.
Yes.
And then when we read Martinus, we know that he says, well, what we call light, what we can see in this room, it's physical light. It's very practical, because then we can see each other. We would notice if we hadn't. You would notice the difference. It was suddenly dark in here. Yeah. But it's not light in its own nature. Martinus would say light is something spiritual, it's something different. Yeah. So I think when they started discovering that, what they call photons and so on, they use concepts belonging to an earlier world view.
Yes. Yeah, and that's a very significant point to Bohr, that the language we use, necessarily, it is, the words are words describing the world around us. And now we're at the quantum level, and the words are not, they're not adequate anymore, but it's all we've got. So we have to use the words. So what we can do, we can describe the setup of the experiment, and then we have wave-like properties, or we have particle-like properties, and as soon as we say wave, then we have a certain image of something in our heads, perhaps like a wave at the ocean or something. But he would say, we don't know what it is. So the properties are the same, but that doesn't mean that it's a wave. We don't know what it is, but these are simply the properties. So for him, it's a I don't know if it's a big problem, but it's a severe limitation. We have to. We only got the words that we got, and they don't really connect to the quantum reality in a way. And that's so he was he gave language and words and concepts a lot of consideration. And that's why he had this view on what's it called, when you have to accept both of the views, that if you have an electron, then we can describe it like a wave, or we can describe it as a particle. And usually you cannot, within science, you cannot have two descriptions of the same object that contradict each other. You want consistency. And Bohr, he says, well, no, we have to accept both. If you want to get the full description of the thing in question, you have to accept both of these aspects, even when they contradict each other. And that was the big shift. And Bohr himself, he considered that his greatest contribution to science, that things are not as we think they are. We cannot expect to have an all consistent, all encompassing system. We just have to accept that we need both of these descriptions if we want to describe the objects in its entirety.
Very, very exciting and fascinating. Now we move on more to Martinus's world picture and sort of put up hypotheses about, what we have all those observations, but perhaps waves and particles could have something to do with discarnated being, incarnated being, movements from the spiritual world to the physical world. And we also have the principle of perspective, which makes, even if we have the same laws, Martinus would say, in the microcosmos as in the macrocosmos, but the time perspective is completely different. So all those things could, of course, contribute to, we have the phenomena that we can observe, but the explanation could be quite different, namely that we actually talking about discarnation, incarnation. But of course that's seen from Martinus's perspective.
But I think, so when we talk about the spiritual realm or the physical realm, I think at Martinus there are different meanings here, because even when we are incarnated or then we still have, we don't have a body like this. It's not a matter in this sense, but it's still physical in the sense that it's energy or something.
It's material. It's matter. It's matter. It's spiritual matter.
In a way. So it's not it's not the same as the X1 or the eye or the center that experiences, because that is outside all of this. So it's still within the framework of physics in some sense. It's just beyond the perhaps current capabilities of observation or whatever. So it's still within the realm of the physical world, but just beyond what we are able to experience or to observe, I think. So in principle, it should still be able to perhaps understand the ways this broadened physical world exists if we were just able to observe all of it. So I think at an even deeper level, this doesn't really exist according to Martinus. It's all perspectives and it's experiences. But then we add an even deeper level, right? So that there are various levels of spiritual worlds, or at least non-physical aspects of reality, perhaps. Like depending on what you mean by the physical, right?
Of course. But as I going back to those different spiritual, for example, comparing perhaps to some Eastern traditions, or also what makes Martinus probably very compatible with Einstein and Bohr, is that he says there are strict laws also in the spiritual realm. There are laws. These energies, they also follow laws. So when we learn to, as he wants us to think about it, we can at least use our thinking and perhaps tiny bit of intuition. But it's not coincidental. There is strict logic inherent in all those dimensions.
Yeah, that's right, yeah. But I think it's still a bit different from at least Einstein's view, because according to Martinus, we do possess a genuinely free will, at least to some degree, right? So it's not deterministic in detail. So we still have the impact of a free will, at least to some degree, but where the physical world works is according to these laws, and there are spiritual laws that sets the framework or the overall way things work, but it's still a combination of genuinely free will and in that way impacting the physical world and then setting things in motion, I think. And I think Einstein, he would not agree to that. He would say, well, reality is, or the physical world is deterministic, but we just have to live as though it was not, right? Because otherwise things would, if we accept that everything is determined beforehand, then it has some existential implications, right? So there are some differences, but I think, so at Martinus, I think he would accept the laws, the physical laws of nature, but then there are these spiritual laws, or as kind of rules of the way existence even functions, or the structure of existence. And that's perhaps at a different level of laws, in a sense, I think, perhaps. Yeah, I don't know how clear or not clear that was.
I mean, it's a deep topic, and I'm just sort of imagining, especially from what you told about, for example, Einsteins and Bohrs and all the other scientists, about their minds, they will probably not stop. They will not stop where they were at the time. They will go on researching this.
Yeah, that would, of course, And Einstein, he spent his entire life trying to understand different things, but he moved away from this particular question of the completeness of quantum physics that he discussed with Bohr. And Bohr, he kept doing research as well. But he also, after World War II, he spent a lot of time trying to convince politicians and to kind of slow down the nuclear race, and he was a bit involved in some of his research laid the theoretical foundation for the further research that led to the development of the nuclear bomb. So I think he felt a bit, I don't know. Well, at least he was a part of the entire process, at least, and I think he wanted to. I think quite early on he saw the dangers of nuclear weapons. And,
it's been, as you also mentioned, the movie, the feature film at the moment, Oppenheimer. You mentioned that, and of course, it gets very clear how those. The worry about how you use the knowledge that you find out. You can use it for fantastic things, wonderful computers, wonderful progress, and you can use it for very destructive ends. And they engaged in that, as you say. But Martinus talks about world, sort of that we have gotten some impulses in the 20th century, sort of inspiration from and one in 1900, one in 1920, and actually really mentions modern science. It seems to me that all this discovery of the subatomic universe that seems so puzzling, and people call it spooky, and it's almost magic.
It is very strange.
and it seems as a very important step in a way that we understand that what as you say, what reality really is. I mean,
well, definitely, and it happened in the 1920s, so it matches very well. In 1913, Bohr, he developed a model for the atom, and then in the 20s we had this. It was an entirely new branch of physics, entirely new world, and they were just excited and discovering all this stuff. But it has led to some very significant, perhaps philosophical changes, or at least changes on the nature of matter. So the concept of matter, I think it's abandoned in contemporary physics, because there's not matter like this. It's all mostly just nothing in a sense, right? And
It's not.
yeah, so the idea that what we experience as physical reality, it's, in a sense at least, it's an illusion.
Yeah.
They will still acknowledge, of course, that there are some physical stuff in some sense, but at the quantum level, you can't really, you can't say anything about what it is. That's Bohr's point, at least.
Yeah.
All we have all the mathematical equations, but the question, and it works very well. So if we calculate this and then we make this experiment, then the results, they matches the predictions according to the math. But what does the math represent in reality? What is it? And he would say, we don't know. We simply have the math and we have the results, but we don't know what it is in itself, right? And I think nobody knows today what is an electron even. We don't know what it is. But it's in all school books, and everybody learns about
those
chemistry
models.
and electrons, and they
Those
can all
models.
talk about it in all the models,
Yeah.
but nobody knows what it is.
No.
No, and that's interesting. Yeah.
It's
So I think it has changed a lot of things. The quantum mechanical, well, I don't know if it's insights, but the development of quantum mechanics and all this, all this stuff. Yeah.
So we were going to wrap it up soon. I think it's extremely fascinating. But if you could try to sort of summarize these, at least Bohr and Einstein, their debate, and then what Martinus gives us in his overall, because he has an all-encompassing world picture.
Yeah.
How could those two meet, or how could we place quantum mechanics into Martinus's world picture?
Yeah. So. Yeah, that's that's one of the great strengths of Martinus's world picture. That it's all encompassing, right? And that includes, as we talked about, both Einstein's and Bohr's views. So if we want to look at it from a Martinus point of view, then quantum mechanics would simply just be the lower level of physical reality, in a sense. And he would say, of course, we cannot say anything about what it really is, because it's outside perhaps both our ability to even understand it, but also our ability to observe it or measure it. So he would say that is how reality is constructed. And that's when we talk about the very, very small things, and it's the same when we talk about the very big things. And Einstein's theories of relativity, they are concerned with the very big picture, right? And then they are very strange as well, but in some other aspects. So it matches Martinus' views very well. Martinus' view very well, that if we get to the very, very big scale or the very, very small scale, then it all becomes blurred. And then it's very interesting that the personalities of Bohr and Einstein, I think you could argue at least that they match Martinus's claim that this intuitive understanding, it has to do with your ethical and moral development, or your character or your personality, or what kind of human being you are, not merely your intellectual capabilities. So I think it's very interesting that Martinus's world picture can kind of it's compatible with both Bohr and Einstein's views. Yeah.
And of course, Bohr and Einstein, they need to describe where we are right now. Martinus describes a completely different viewpoint with full intuition, where you will actually be able to travel down to the super microcosmos and find exact order, but that's in the future. That's not right now, exactly as you say, and right now it becomes blurred to us, because we have our what he calls mesocosmos, and that's where we can investigate things.
Yes.
But of course, we want to go further, and that's part of human longing. What happens in the,
but I think that since the development of quantum physics, it has I don't know if it's it has all the level the rate of progress had slowed down a lot, and today there are a lot of models, but even with modern technology, the scientists can really dig deeper than this. So
interesting.
it was a big leap in the 20s and in the decades before with Einstein, and since then it has kind of decelerated, I think, in a sense. So that would match Martinus's point of view, that there's some kind of limit to what we are able to do regarding this.
With limited intuition.
With the scientific methods, you might say.
It reminds me once what the German author Gert said, because he just said that the proper study of mankind is the human being itself. It sort of comes back to that, of course, what we're really investigating here. That goes back to many philosophers probably, is actually what can we investigate and perceive, even if we try to prolong our physical eyes and senses with equations and instruments and all sorts of things. But we are studying, in a way we are studying ourselves.
Yeah, we are. And Bohr, he was very fond of Goethe, actually.
Yeah.
So Goethe was one of his inspirations, I think. So he has this concept of complementarity, it's called in English, and he said, I think there's something along those lines at Goethe and Eastern philosophy and stuff. So Goethe is mentioned specifically. So I don't know if that's the reason you brought him up. Or
I'm just thinking about it. We always have to remind us that nature isn't sort of just there. It is there in a sense. We will be walking out in a few minutes and have dinner and so on, and you will actually give another lecture about Darwin and evolution. That reality is there, and it's good that we can trust that it's there tomorrow as well. I think it gives stability.
Yeah, it does.
But of course, to another being, the same reality looks quite different.
You're right.
Of course. And it could even look slightly different to the two of us, depending on our different lenses and glasses. And
that's right.
And then, of course, we get into your main topic from your other interviews, consciousness, and what is that, and what do we know of our consciousness?
Yeah, that's right.
Is
not a lot, it seems.
Where do we go from here, do you think? It seems to me, I might get it wrong, but it seems to me that you're implying that in a way we can't get so much further into quantum physics or quantum mechanics.
Well, at least that is how it looks when you look at the kind of the results. There are perhaps 50 models or something. I don't recall the exact number, but there are so many ways you can interpret the results of the experiments, because you cannot detect these small particles themselves. You can only detect their effects, and then you have this model that matches the results, and this model matches, and this model matches. So it's a different kind of science that is done now compared to at Bohr and Einstein's age. It's computer simulation and just, I don't know, throwing out models. So I think it's well, I don't know if there'll be another break. Nobody expected quantum mechanics to happen, right? Or Einstein's theories of relativity. So of course something could happen, but I'm not sure that it's just around the corner.
We don't know, but it happened in Copenhagen, it could happen in Copenhagen again.
Yeah, it could happen in Copenhagen again, perhaps. Yeah.
We don't know, but
no.
I think we'll wrap it up for today. But thank you so much for joining us.
Thank you.
Great interview, and I look forward to continuing talk at another opportunity. So thank you, and goodbye, and thank you for listening.